Welcome, everybody, to the AI Engineering Bootcamp, cohort number 5. Welcome to session 8. We are at the end of week 4. It is flying right on by. Today, we talk RAG assessment metrics, and we're going to do 4 things today. We're going to build a RAG app. We're going to evaluate the RAG app. We're going to build an agent app. We're going to evaluate the agent app. And we're going to do all of this in 2 hours. And that is kind of the theme of where I want you guys to be thinking you are and position yourselves accordingly heading into the rest of the cohort and the rest of year 2025. Shout out to the build chip shares going on. So much good stuff going on. I'm only going to shout out the ones that are being shared publicly now. Praveen, Deep T, you guys getting it in on X. I'd love to see all of the shares out there. We are reposting as much as we can. Shout out to Ben. That is a good looking post right there, Ben. Love that. Love the visualizations that we're seeing, whether it's over here with Ben or over here with Krishanu. Way to go, Krishanu. Love to see you on the path, my man. And then, of course, Ashwin and Tom getting after it per usual. We are seeing a lot of build chip shares happen across Discord as well. Shout out to everybody getting it. And we picked out some great lessons that I really like from you guys. What a big ocean Python is. Yeah, for sure. How incredible some of these open source tools are. Absolutely, more and more every day. What a pace. And even today, we'll see the pace does not stop. Fancy RAG actually making sense. Love to see that. Love to see that. Shout out to Homework 6 multi-agent, build chip shares. So much of building a good agent is prompt engineering. I love this because actually that's the secret, guys. It's prompt engineering all the way down, all the way down. And that I think is kind of the whole, hottest new programming language is English kind of vibe that everybody's always talking about. Really, that is what we're talking about, is these prompts. And then shout out to Mike C for keeping us posted on the brand new Ragus release. So we're going to get hands-on day of the latest Ragus release. Not necessarily a whole lot you guys need to worry about, but check out the changelog as you start working on it. Some of the stuff is related to metrics. So for instance, check out this faithfulness here. We'll talk about faithfulness later. Lots of good stuff in the changelog. Let's see what you guys thought about last time. We got some good feedback, and you guys are really helping me out here because I see very minimal, ridiculously positive feedback anymore. So thanks for that. We're getting good numbers, but you're giving very useful feedback. Absolutely love the breakout rooms. This was a particularly awesome one that I thought noticed a big difference in my comprehension. Not going to the breakout rooms versus going to the breakout rooms. I'd love to see this. Sometimes I feel lost, but today I got everything. Let's go. I hope that that's going to start to be something that feels a little bit more normal for you guys in the coming weeks as we have the breadth now. Whoever designed the breakout sessions achieved perfection. Well, this is an evolution here. It is not top-down prescription. It is part of the whole team coming together. So I'm glad we can continue to try to make that happen. We'll do our best to follow it up strong today. More code walkthrough time. I am putting my foot down. He gets no more code walkthrough time. Wiz got as much as we could possibly give him last time. It's just, we're at the limit. Okay, we want to give you guys lots of breakout room. We want to give you guys lots of Wiz, but that's as much as we can get. Okay, we're hitting the limits of Wiz walkthrough time. And we hit the limit last time. So I'm sorry, I gotta shut it down now. You keep asking, we've hit the end of the limit. Okay, so I would love to see how I could start with my own seed of ground truth questions. This is a great point. And in fact, it's totally aligned with best practices. More levers to pull to change the system. We'll do this today and we'll keep doing this basically throughout the entire cohort, or at least throughout the prototyping part of the cohort, because it really is all about improving the system once you get it up and running. Simpler explanations of the concepts. I'm trying. Give me some specifics. I will change and I will try to be better. More pictures. We got some pictures for you today. We've got some open source models coming soon. Okay, we try to focus on the topics at hand and not throw a bunch of additional complexity, but open source is coming, so no worries. We will see llama models in due time soon. I feel like I spend a lot of time making things work that should work. Ah, what a good comment that is. Yes, I believe this is the name of the game in any engineering role, no matter if you're dealing with hardware, software, or anything. You really don't get to spend time on the stuff that you really want to most of the time. And this, I think, is part of the AI engineering process versus maybe some of the data science stuff, really where it manifested in just playing with the data most of the time. A lot of it is chasing down errors, and that's just the way it is. I want to build more, but I feel like I'm still consuming concepts and don't know enough yet. Well, I think you do know enough already, and I think you guys know way more than almost anybody in your network, full stop, just over these 3 or 4 weeks building, shipping, and sharing with us. So we'll come back to that in just a moment here. It would be good to record the breakout rooms. I just want to let you guys know, I can't record them for you. You're going to have to work directly with your peer supporter to record them in your breakout. And we can make that happen. We can make sure that you can do that, but we can't record them all at the same time. It's just not a feature in Zoom. If it was, we'd offer it up and just give you access, but we can't. So you can work with them and they're happy to record for you as well. It might take a little setup. I feel that we're missing some high-level concept or user story that describes the use case. Yes, we keep getting use case questions over and over. What's the detailed use case? What's the detail? These are the right questions to keep asking. Our focus is and will continue to be on engineering tooling, but I'm going to put a pin in this one too. We're going to come right back to it, okay? A couple more things to share with you. This was very useful for me. Thank you for this. I will add this clarifying thing to SDG next time I teach this. How we were creating the knowledge graph from 2 HTML docs. I didn't understand that we were processing it with LLMs to extract the entities and relationships. This is exactly the kind of feedback I'd love to get. Thank you for this. I will make sure that this is explicated more clearly next time. Explain a bit slower the concept of nodes, content, and synthetic data generation. I'll do my best. That I will promise you guys. Okay, what's the business impact with the SDG? Wiz, there's just so many places to use SDG. This is almost too broad of a question. We can use it in training. We can use it in eval. We'll talk about eval more today, but I'll give some stuff for training. Obviously, it's related to this distillation thing. What do we mean by business impact? I mean, what's your 2 cents on this? What's the business impact of SDG? Saves humans time.
Yeah, saves humans time. Model development is accelerated. We can get evals faster, better, stronger. There are so many different ways that SDG can be leveraged. A weird uh distillation is what I'm going to call it. All these things. SCG is just basically the best. It also doesn't cause the model to experience collapse or catastrophic forgetting unless you get real crazy with it. So, the
No
idea
catastrophic
is
forgetting. People like hearing that.
that's
No
right.
stations, no catastrophic forgetting. Tell that to
That's
your
right. You
bosses.
you don't have to know what catastrophic forgetting is to understand we probably don't want it to occur, right? So it's but yeah, the idea is SCG is just so powerful. Also, we have a lot more models now than we used to that allow you to train on their outputs. And so SGG becomes more and more of a viable strategy, up to and including the most recent, everyone's favorite R1 model. So yes.
Yeah. Lee
It
Sun,
impacts all layers of business, basically.
Lee, the GitHub of SDG. Love this in the chat here. The buzzword of buzzword, let's go. Yeah. I'm not sure how that's going to work out. I'd like to hear that specified. What do you mean by SDG? That's what I'm going to ask that founder. Okay, so let's go ahead and go to this next. This is the next awesome question. Shots fired on Ragus. What's it even good for? Just chat apps for real? Is that all we can do Ragus for? What do you think, Wiz?
Uh, no. But yes. I mean, so it's okay. Like a kitchen knife is made for chopping vegetables or whatever, right? But like, you can also open boxes. It can also, it can help you, shave off a piece of fractured wood. I don't know, whatever other things you could use a knife for. I
Whittling?
think,
Yeah.
yeah, I'm chain of thoughting currently, right? So, but the idea is that no, Ragus provides a fairly universal set of metrics that are first and foremost designed for RAG. Of course, it's in their name, it's in the tools names. But like, someone raised this point. Like, what about for video games? Well, for video games, we have a scripts that we want our characters to stick to, right? We want things like a quest giver to give correct quests based on where you are in your hero's journey, right? Well, things like faithfulness are still extraordinarily useful for determining if those NPCs are doing that thing, right? The actions that you're supposed to be taking. So should you be setting off on the adventure at this time or not, right? Well, that's also something that we're going to see from today. Can be covered by something like tool calling accuracy. So
Mm,
yes, of course, the metrics were designed first and foremost for RAG, but we can absolutely and trivially extend them to a lot of different use cases. Because they're measuring things like how close do you stick to the script? How much do you allow yourself to change or grow beyond a certain piece of context, etc. So
mm,
design for it.
that's right.
That's not where they're locked in, though.
That's right. Okay. Piercing question. Great stuff. And then Dr. Dean is dope. Let's go, Dr. Dean. And then great help from the support person. Shout out to the support room, guys. Todd and Duke, you guys crushing it. Let's go. Okay, I want to go back to two pieces here. I want to build more, but I feel like I'm still consuming concepts and don't know enough. One, I feel like we're missing some high level concept or user story that describes the use case. Two, okay, both of these things are kind of true, and they both start with I feel, okay? But here's what I have to tell you guys. You now know enough, okay? You know enough to be very dangerous and to be very useful and to be very valuable. But we have to put it together with other pieces of the stack, okay? We have to think about how this works within the context of our businesses, in the context of things that already exist today, in the context of what we're doing with our customers. We are talking all the time about how to build, ship and share, but do you know enough about really going end to end? Do you know enough about what to build and why? This is where we get back to where we started, right? We're not talking about problem, success, audience all the time because this isn't an MBA case study course. I want to build that one day, but this is not it, nor will it never, ever be it. Okay, this is not a product manager's course. This is an engineering course. And so we are focused on building engineering solutions. Most engineers, they literally don't really care about exactly what all the problems are. However, the best engineers do care, and they become the leaders of engineering teams. We want you guys to go end to end with Demo Day. We're going to give you guys distribution. We need you to bring the heat with your story and with your build. We've helped organizations do this through our boot camp. Organizations like Veterans Affairs, Chris took our boot camp. He's crushing it within his org. Organizations like Hrvatski Telecom over in Croatia, their whole team took our course. They've now crushed it. They are really, really making a big, this is like T-Mobile in Croatia. they're making a huge impact over in their company. So I want to introduce you guys to an opportunity that we'd like to throw out to you guys. We're going to help you build some bridges for demo day. And there's no other guy that I feel like is better suited to help you than my boy Lusk over here, who helps me build bridges into corporations. Lusk, what are you looking for, and what can you potentially do for people?
Killer meme, by the way. Help me help you. Great one. So Greg and I, we are exploring some ways to help you, our client, better position yourselves to your managers, your team, your executives, and potentially future employers. And so the goal of this initiative is to help you bridge that gap between what you're learning in this boot camp to the actual needs and demands of your company. And as I was seeing some of that feedback, I was like, I feel a lot of self-doubt in here. But to echo what Greg said earlier, after 4 weeks of this boot camp, like, you guys are the experts. And also you are uniquely situated to build Gen AI solutions that can solve real, practical, profitable solutions or problems for your company. And so if you don't know what problems to solve, if you don't know what problems that your company wants to solve, if you don't know how they plan to solve them, if you don't know what their biggest concerns and pain points are, that's something that I can help you with. And so Greg and I were talking, I think I want to work with 4 or 5 people to help you connect your demo day projects to your company's AI objectives, help you look like a legend. And so if you're interested, I'm going to drop my link here and I want to hop on a quick 15-minute call. Again, it's still something that we're flushing out, but I want to help you guys bridge that gap between what you're doing here and what your company is requiring of you, or maybe the things you don't even know of yet, so we can help you look like a legend.
Thanks, Lusk. Yeah, we're going to drop that link in the chat. So go ahead and book with him if you're interested. This is the kind of thing that would get your manager to demo day and get you working on problems if you're not quite sure what to work on. Lusk can help you do some of the hard work to sort of navigate the internals of your org and get the right person to answer the question, what are you guys really working on and why? So this is a capability we're building out, sort of a consulting arm of the company. And if you're interested in bringing AI engineering into your company and potentially being a leader in the future, this is going to be something that you want to check out. But for the rest of you, it's time to go ahead and get on with it. The one thing I want to mention about demo day is we're going to return to this idea of what are you building for demo day next Tuesday. For those of you that like aren't in a large corp, aren't quite interested in this kind of thing, just want to build cool stuff, just want to do a passion project, we're going to be focused on exactly what we're building and how we're going to do it starting next week, heading into the midterm week thereafter. All right, so today what we want to do is we want to go back to RAG eval. We want to go back to synthetic data generation. We are going to use RAG and agents and eval, all of it today. We're going to do a RAG app, we're going to evaluate it. We're going to do an agent app, we're going to evaluate it. Now, the first thing that I want to just do a quick review of is this idea of synthetic data generation. Shahul, who's one of the co-founders of Ragus, made a post today posting about his blog he wrote in November when they sort of underwent a lot of these changes at Ragus. And it's just the big picture here that's important to keep in mind is that the bottleneck for evaluation focused SDG is that it's hard to come up with golden data sets. And we have to deal with that. It's hard to get humans to do this. But humans don't get off scot-free just because you're using SDG, as we'll see. The solution is we need to generate a sufficient number that are diverse and representative and high quality. So like, they have to be representative, they have to be diverse, and they have to be high quality. That's like the trifecta, right? Now, when we talk about diversity, we saw some of this last time. Define the personas, define the scenarios, give it a place to stand, the persona. You know, if you tell it it's sunny and it's kind of gloomy outside today, the LLM is going to give you a much different response than if you tell it it's bright and sunshiny and everybody's smiling. It's just the way it is. You have to give it a place to stand, And then you have to seed stuff. We talked about seeding in the questions that we got on feedback. This is an important question. How do we seed this kind of stuff? How do we take words that matter to us, information that matters to us, to help seed this, to get that more diverse perspective? How do we also at the same time make sure it's representative of the way people will use our apps in prod? And again, this is emerging. Quote, some strategies that they've explored. Sampling a few queries from production, literally after it's already operating. This isn't a previous ML paradigm where we build, we ship to production, and then we've already done all of the evaluation a priori before we ship. It's actually, we're doing the evaluation after we're shipping because we need to see how people are starting to use it. We need to generate that data so we can generate more of it. Or extracting some of the scenarios, some of the query types, some of those specific details we want, and then using those to kind of build out our knowledge graphs and generate our synthetic data. Either way, you're taking data directly from production to become representative. So hurry up and ship, right? And then do more SDG and evaluation. This is like LLM ops, right? And then quality. Quote, this is the hardest part. Hey, look, actually, in the end, we still use humans to be like, yeah, is that cool? Yeah, it's cool. This is where we are, you know? We want the AIs to go all the way down and do it up and down the whole stack, but it's just not the case. And you can do a lot of stuff, but at the end of the day, you're going to have to make sure that that is aligned with what your users want. Okay, so read the whole thing. Highly recommend it. It goes beyond evaluation. It goes into things like training. And by the way, there's this pretty dope blog on training. I really like it, and I really like the flavor of writing in it. You guys might want to check it out. NVIDIA released it in June last year. It's on a model that maybe nobody's talking about anymore, but it's the same idea of how we use SDG for training. Okay, so let's talk about RAGs. Let's talk about how we're going to actually take the data and do the metric calculations. We want to make sure each metric is focused singularly, that it's intuitive, that it's interpretable, that we can think about how the numbers are changing and make trade-off decisions when we switch out components and parts. We want to hopefully have ones that have consistent scoring ranges that we can bound and we can say, hey, oh, we're out of bounds, something's wrong, shut it down, don't send it to the user. And remember, where it sits in our stack, we want to get data that is representative of question context and responses, right? Because we want to get those key metrics. We want to make decisions about prompts, about retrievers, about text splitting. We want to make decisions about vector stores and models and fine tuning. And we want to make decisions about, okay, now it's good. Now we're ready. Now we're going to go to production. What we're going to do today is we're going to build a RAG application and we're going to slap a little re-rank on here. I think Wiz mentioned this already. And re-rank is optimize your search with one line of code. It's a pretty easy way to start optimizing, okay? Re-rank goes right here. The context that gets retrieved then gets re-ranked. Okay, so we're going to draw a box around this. How? And what are we going to calculate? How are we going to go from A to B here in our little box? Well, our box is going to consist of question, response, context, reference, and our metrics are going to include a few things. Importantly, we're going to focus on LLM-based metrics. There's a lot of non-LLM-based metrics, and we've talked about some of those, exact match, et cetera, et cetera. You can do that kind of thing as well, or must contain, that kind of thing. But it's important to remember, like in RAG, we're doing retrieval. Whatever we chunk, that's what gets retrieved. So ideally, there's like a correct top chunk for any given query, right? There's a golden chunk, right? And we can extend this idea into agentic systems as well. So what we're going to do is we're going to take these pieces of information and we're going to calculate stuff from them. The first thing I want you guys to understand is we're going to calculate context precision and context recall. This is important. So remember recall and precision and F1 score, right, from back in the day. True positive, true negative, etc. Okay, The point here is that precision basically asks, how many retrieved items are relevant? This is so great, right? Because this is literally from the Wikipedia page on precision and recall. And then recall says how many relevant items are retrieved. How many retrieved items are relevant? In the context of RAG, this is quite useful because context recall is literally just talking about the context that we're doing and retrieving. So let's look at context recall. For each reference, that means ground truth, we're going to break it down into claims. Each claim is then assessed by an LLM. Can this be attributed to the retrieved context? We can do the same thing with the entirety of the context by breaking down into claims as we can with each entity that's called out in each reference. And we can do the same thing with the specific entities. Obviously, named entity recall, NER, is a big thing in machine learning and NLP in general. This is an extension of that kind of vibe. So we're basically asking, was the context recalled? Okay. That's the first thing we want to see. Did I get the right stuff in context? Then maybe the way to think about this is we want to measure the relevancy of the retrieved context to the question that we asked. This is it's like asking, well, was the context that I recalled also precise? Was it also very relevant to me? If it was not relevant to me, bro, that's just noise to me. That's just noise. And so the sort of leftovers then, we can sort of think of those as how sensitive is my system to noise? And this is the idea of noise sensitivity. So we can kind of look at the retrieval metrics here as focused on the context and focused on making sure that it's associated with the question, making sure that it's directly aligned with the reference. Makes intuitive sense, right? But you got to make sure those references are right, what you want. When we talk about generation, there's a couple of additional metrics that we want to look at. The first one is called faithfulness. Everybody loves this. It's a great name. Everybody wants their apps to be faithful. What does it mean? Well, you can say this, and this will impress people. It measures the factual consistency of the answer against the given context. What does it do? Well, it basically solves this problem for us of hallucinations. We don't want you to lie to us. We want you to be faithful to us, 100% faithful, nothing less. Don't lie to me, please. And then we want also all of our answers similar to being relevant to the question up here. We want it to be relevant to the question down here. And they actually changed this. It's not called answer relevance, although you might find that in the doc still. It's called response relevancy. And I mean, what do you think it does? It measures how relevant the answer is to the question. Now, this is an interesting and curious one because an answer is deemed relevant when it directly and appropriately addresses the original. Well, I don't know how you would calculate that, but they came up with a pretty slick way. But here's what they did. They said, well, we're going to take the mean cosine similarity of the original question to a number of AI-generated questions based on the answer and the context. The big idea here is that for any given answer and context, you could actually be asking different questions. Or, you could sort of flip this around and you could sort of say, well, how many right answers are there for the same question? And maybe that's not as clear that there is more than one. There's certainly different chains of thought that comes into play as we build these kind of apps, but not with simple RAG. Now, this is cool because really the idea for RAG in the first place is to use this mean cosine similarity, is to use cosine similarity and other similarity metrics and embedding space to find the docs in the first place. So there's a consistency here that's, well, I don't know, somehow somehow it fits. Okay, when we go to evaluate, we got to ask, what are we building? Well, we're going to stick with what we've been building for the past couple of classes. Our RAG build is going to be with our buds. It's going to be with our bud Simon and his blog stuff. And we're going to see how it works with the Wiz, who I'm going to send it over to right now to show you how to build a RAG app, evaluate that thing, and then improve it with re-rank. Wiz, over to you.
What's up? Okay, so basically, part of this we've done before, and part of this is going to be new. But we're gonna see the kind of initial creation of this RAG app, a number of times, so it sinks into our bones. The idea is pretty straightforward. We are going to install all of our prereqs. We've done this before. And then we are going to provide some API keys. We can provide both our OpenAI key, API key and our Ragus app token. Ragus has kind of like a little dashboard that you can use now. Very cool. Go Ragus. We're going to use that same data that we saw before, which is the kind of, state of AI report from this Simon Willison. Then we're going to load it, and we're going to skip all that stuff we did on Tuesday, right? We're just going to go straight for that test set generator this time. So remember, we don't, we already kind of looked at that SDG process. We already unrolled it. This should be, something we can just do now. So we're going to do it. We create a bunch of stuff. Everyone's happy. We wind up with a big test set, 11, technically 12 questions. Go team. And then we're going to go ahead and start building our RAG graph. Again, this is hopefully table stakes at this point. We're going to just load our data. We're going to chunk it up. We got a question. What is chunk overlap doing here? Why do we care about it? We've talked about it in class, but put the answer down in stone, as it were. And then we're going to use text embedding 3 small as our embedding model. We'll just zoom in a little bit there. Text embedding 3 small, which is kind of the standard embedding model from OpenAI. We're going to create our quadrant client. We're going to create a collection in it, and we're going to store some vectors in that collection by turning it into a vector store. Then we're just going to upload or upsert all of our documents. We're going to have our retriever with a K of 5, which means that for every query, we're going to get 5 top documents. And then we're going to build a retrieve node. Remember, we're making graphs here. All that nodes have to be is just wrapping the actual thing we want to do in a Python function that takes state and then returns as a modification to that state. Someone asking in the chat, should we do this locally in Colab? For every assignment, which you can do locally, we're going to ask that you try to do it locally, depending on what your room is doing, what your breakout room, what they've been doing so far. The idea is that we really want to make sure that people are able to run this locally. It involves some setup. It can lead to more troubleshooting, but more troubleshooting is more better. That's where all the learning happens. Okay, we have our RAG prompt, just stock RAG prompt, gotta love it. And then our generation, we're going to use GPT-4o Mini because why not? It's a good model. And then we're going to go ahead and generate, in our node. All this is going to do is going to take from state our context and put it into a double new line separated blob. Then we're going to go ahead and format our messages with that, as well as our question from state. We're going to invoke our LLM on the actual resultant messages, and then we're going to return that response as a modification to state. Nice. Speaking of the state, we're going to go ahead and create our state object. We have our question, context, and response. This is pretty straightforward. Question is going to contain our question, context, and response, our final response. Then we're going to create the actual graph. Remember, because we're just doing a RAG graph, we add a sequence of retrieve and generate, and then we add the edge from start to the beginning of that sequence, and then we can compile our graph, and away we go. We can then ask our graph a question by invoking it. and then we can push that to, because that's pushed to our state as part of the graph, we can extract the response from state. Very cool. Okay. So that's all stuff we've seen, can do, are good at, etc. What we want to do now is actually evaluate the thing with Ragus, which is not a complex process. So if you'll permit the scrolling, right, we'll scroll back up to where we create our data set. You'll notice that we have user input, reference, context, reference, right? But we don't have like our solutions response. So what we're going to do is we're going to go ahead and we're going to add that solutions response by just looping through each of these particular questions and appending our response. You can do this a little bit better or more cleverly, but to make sure that we're staying within everyone's rate limits, this is the way we're going to do it. If you have been using this services for a long time, you can use async to speed this up, but this way is likely to prevent you from running into rate limiting issues. What we're going to do for every single row in our data set, we're going to ask the question based on the row of the data set we're in, which is going to be the user input. Then we're going to save that response as a new column called response, and then we're going to add our contexts as a list of contexts. So what you're going to see is before we had user input, reference contexts, and reference, now we have retrieved contexts and response. And retrieved context is going to be what we actually retrieved, and then our reference context, response is going to be what our system answered. So what that means is that we have effectively built out the rest of this test data set, right? Where we've populated it with information from our system, which is great. Now we can convert that to an evaluation data set from Ragus. We can also wrap our LLM with a Ragus LLM LangChain LLM wrapper. You can imagine that this just makes sure that this LangChain based LLM works in the Ragus ecosystem. We're going to go ahead and set a custom run config of 360 seconds. You may still run into timeouts here. If you really wanted to, you can make this larger, and it's going to restrict the amount of timeouts that happen based on the usage tier you are in of OpenAI's APIs. But the effective idea is that this is going to make it take longer, but complete more. Now, the actual process of evaluating is done by evaluate. We pass in the evaluation data set, which is kind of our completed data set, and then we are going to pass in a bunch of really fun metrics, including factual correctness and noise sensitivity. Very fun, very fun. Okay. We're going to then pass in our evaluator LLM, which is the wrapped LangChain LLM, and then we're going to pass in this custom config so that it doesn't time out on us as much. So what are each of these doing, right? Because like this is a this is not very kind of useful by itself, right? It doesn't really tell us what's happening. So what we're going to do is we're going to dive into the old Ragus, and we're going to look at some code together, which is going to help us try to understand what exactly is going on with these metrics, right? So like, let's say, for instance, we have our many apologies. We have, our LLM context recall and our noise sensitivity, right? What are these things doing? So what we can do is we can come to our docs and we can look at, say, noise sensitivity, and then we can check out what's happening underneath the hood, right? So this is what I'm going to basically ask you guys to do, is take a peek at how they're implemented, right? You'll notice that we have this as a metric with LLM. It's a single turn metric. Okay, cool. We have a bunch of ways to start it up. So it's single turn. That's great. Evaluate statement faithfulness, right? Okay, so this is good. Decompose answer into a statement. Okay. Compute a score. Interesting, right? But basically what this is saying is we're going to look to see, right, if the noisiness of the question has a significant bearing on the actual, final response. We look at another one, like let's say we wanted to learn about LM context recall, right? So we can say context recall, cool, and we could just go ahead and see what's happening under the hood, right? The idea of context recall now is going to be explained to us in the code. We can see that what it's going to do is it's going to estimate context recall by estimating true positives and false negatives using an annotated answer and retrieved context. We can see that the compute score is basically saying 1 if it's attributed or 0 if it's not. We get our denominator numerators classic, right? Everybody knows, of course, division. But the idea is that for each of these things, we're going to score based on whether or not this kind of context was present in our original reference context, right? So how well are we retrieving the correct context of what this is saying, right? We're saying, okay, we've got our user input, right? We've got some retrieved context. We have an answer. This is going to be this QCA, which is just question context answer, to be clear. And we're basically going to say, like, hey, what we're trying to determine is whether or not, right, the retrieved context was relevant to our response. And so what this is telling us, what this is trying to hint at for us, right, is that our system will be better if the context we retrieve is relevant to the questions we're asking and the answers that we're providing, which is true. I mean, it makes sense, right? So each of these metrics can be explained basically, by looking through that code. I would suggest you do that. These metrics are extremely powerful, and again, they're very flexible, though they're designed for LLMs originally. So we're going to get this blob. Now, this blob, let's zoom in a lot so we can see the blob really well. But the blob is basically saying, okay, so context recall, 76% faithfulness, pretty good. Factual correctness, mid, right? Answer relevancy, okay, this is all great. But it doesn't mean anything, right? Like this is not like yes, you can say, okay, well, if factual correctness is very high, that's probably better than if it's not very high, right? But like, what does this actually mean in terms of our application? What doesn't mean anything, right? This is just the stock, the baseline. So what we need to do is we need to make some adjustments. The way we're going to make adjustments is by adding something called a re-ranking, a re-ranker. What a re-ranker does, very straightforwardly, we'll look at it. Instead of retrieving just 5 documents, we're going to retrieve 20 documents. That's 4 times more documents. The idea of the re-ranker is to be a more expensive, slower way to determine semantic relatedness. So remember, from when we first started talking about RAG, that the whole engine is kind of powered, it's kind of beefed along by our fantastic little embeddings, right? We just compare embeddings. Well, you can imagine that re-ranking does that, but like better. But better has a cost. It's hella slow, right? So what we do is we pare down the amount of documents we have, and then we use re-ranker. So we use the fast, computationally efficient process to go from like 1,000, let's say, to 20. In this case, it's not a lot, but we pare down with the re-ranker or with the embedding, semantic similarity search, and then using the expensive but more accurate process, we re-rank and we extract the top, in this case, 5 most relevant pieces of information. This is the idea of re-ranking. The way we implement it is through what's called a contextual compression retriever. Contextual compression retriever is a fun way of saying that we're going to compress the context. So that's all it's doing. It's saying we're going to retrieve, and then we're going to compress the retrieved context, right? So we're going to take it from 20 and turn it into 5. We're compressing that context. The actual model we're using is going to be re-rank v3.5, released late last year from Cohere. Cohere's got the best re-ranker on the market. Don't know what else to tell you. Always use re-ranker. from Cohere if you're going to use one, if you can tolerate the API. Otherwise, pick whatever one off the shelf. This is all we've done, though, is change the retriever. This is important for Ragus. You only want to make one change at a time, right? This is like most systems. In order to determine if the change is meaningful, you should change one thing and hold other things constant, right? So what we're going to do is we're just going to change the retriever, the R in RAG, and then we're going to go forward. We're going to produce exactly the same graph that we did before, so I'm just going to blitz past that. We're going to do exactly the same thing we did before, which is now that we have the synthetic data, we're going to go ahead and answer these questions using our brand new process. And then we're going to evaluate again in exactly the same way we did before. And we can see that the metrics are different. Are they better? Are they worse? This is a question for you guys to answer in the breakouts as you do the evaluation. And I'll pass you back to Greg, who will get us into those breakouts so we can get evaluated with Ragus.
Let's go. Time to get some evaluation going. Time to look hard at these metrics. Time to think about the whole end-to-end stack. So literally, in this next 25 minutes, you're going to build an app. You're going to set up synthetic data to be able to test that app. You're going to then test that app. And then you're going to change something on it, retest it, and decide, is it better? Is it worse? This is exactly the kind of thing you're going to do at your jobs as you build, ship, and share like legends to production. 25 minutes. See you guys back. We'll take a quick break when we get here. See you soon. And we're back from the break and from the breakout room. It's time to talk about agents, and it's time to talk about Ragus for agents. Now, this hopefully brings a number of things that we've done together. Remember how we talked about evaluation samples that we build using SDG and Ragus? Well, now we're going to talk about these multi-turn samples because we need to think about stuff that requires multiple steps to get to an answer, multiple, reasoning steps that we can trace, sort of a plan to solve the problem. So, for agents, remember when we ask a question, it goes to the agent takes an action that gets fed back into the conversation thread, and then maybe we get an answer. We could have tools in our toolbox. And, one of the questions we might ask is, did I call the right tool for the job? Another question we might ask is, did I help the user achieve their goal? Did I actually answer the query? And then beyond that, it's sort of like, well, what exactly could I ask here? One question is like, I can look at the conversation thread. I can look at the chains of thought. I can look at what the agent was thinking and reasoning. Was that right? Is that something a human would do? So instead of like this setup we have for RAG, where we have question, response, context, reference, in agentic apps, we want to use the trace. We want to think about ways we can use the trace. We want to look at, again, how users are using it. We want to assess how we might solve this problem without the AI. The trace is just a log, okay? It's just using the logs. And, I talked to the other co-founder, Jithan, and he's like, yeah, we're just using the logs right now. They're still figuring out exactly what this looks like. They don't have it figured out yet completely in Ragus. One of the things I want you guys to think about is this idea of the golden chunk. If you're just trying to find the golden chunk, what was the exact right chunk to answer the question? Well, in an agent application, what's like the golden trace? The exact chain of thought the human would have used to answer the user's query. And so if you have that idea in your mind, you might say, well, what are the metrics that I could use to assess that? And we don't have them yet. Okay, we're out here way on the edge when we're talking about agents here, but we have 3 metrics and we'll talk about them real quick. Topic adherence, tool call accuracy, and goal accuracy. Topic adherence is pretty straightforward. Are you adhering to the topic? Okay, we want to stay relevant. We want to provide assistance related to the topic. Let's think about our old friends, precision and recall. Well, it's kind of the same thing that we're doing with topic adherence here. Although, instead of how many retrieved items are relevant and how many relevant items are retrieved, we're saying how many answered queries adhere to the reference topics and how many answered queries do not adhere to the reference topics, how many queries that should have been answered were refused. And so we can sort of like do the same thing with topic adherence as we were doing with retrieved context in an agentic space. Okay, keep thinking about that one. Discuss that in your breakout rooms. Also, tool call accuracy. This one's super easy. Use the right tool for the job. But we need a ground truth reference. How do we know it was exactly the right tool? How do we get reference tool calls? Well, right now we do the same thing we did with the RAG. We use the logs. We can use the logs and maybe synthetically generate other similar logs with the idea of maybe there's multiple chains of thought to the same answer, or there's multiple chains of thought from the same question. We're not exactly sure how to do this yet, and it's going to depend on your application. Agent goal accuracy is very, very simple. Did you help the user answer the question or achieve the goal? So let's look at how to draw a box around this with Ragus for agents. I wouldn't be surprised if they change their name soon, and then we have to change all these slides and all these repos, and you'll remember back in the day when it was called Ragus. Let's talk about how we evaluate an agent application. What are we building? Well, we're going to ask a question, and we're going to go and we're going to use a tool called Get the Metal Price. We're going to set up a metals.dev API key, and we're going to ask, did I call the right tool? We're going to ask, did I help the user achieve the goal? And we're going to ask, did I stay on topic? Let's see how it works. Wiz, over to you.
Oh, yeah. So, agents, Ragus. What more do you want? So, we're going to start by getting some dependencies, and then we are going to get our metals.dev API key. Okay, very important step. You're going to navigate to metals.dev. You're going to log in, sign up. They're going to give you an API key. There you go. Okay, it's free. You get, 100 metals.dev calls a month. So if you really want to know about metals, you're going to have to pay a little bit extra. We're also going to use our OpenAI key. So why are we getting metals.dev? It's just to have like an agent, right? Just to have an API. This is a fun example from the folks at Ragus where they used metals.dev. Why not? Okay, there we go. Okay, now we make a tool. The tool is going to be called with metal name, and then it's going to provide some kind of price, right? So this is the first thing about our agentic evaluation, right? Agents use tools for the most part. And what that means is that a part of evaluating agents is evaluating tools. So we have this tool, and we also can think about like how we would evaluate it, right? How do we know that this tool is being called at the correct time, in the correct place, in the correct way? These are all things that we have to answer about. Okay, now the next thing we're going to do is just build an LLM. We're going to bind tools to it. Classic. We've done this before. We're going to make our simple graph or state. Then we're going to create a should continue. We've done this all before. We're going to have our call model node. Again, something we've just done before. And then we're going to create our assistant node, which is going to be essentially what we've called before the tool calling node. And it's going to, help us. We're then going to create our tool node, which is going to be what actually uses the tools, right? Because our assistant tells us which tools we should use, and the tool node is going to be the thing that executes them, right? Again, things we've seen before. We're just going to create our graph, right? We add both of our nodes, we add our start, we add our should continue and our conditional edge, we add our final edge, and then we compile and we draw a pretty picture. So we've seen this picture before. We come into our agent. We can go from the assistant to tools, which will go back to agent over and over again until we're done, and then we go to end, right? This is it. That's all we're doing. So it's the same agent that we saw in the first notebook of our agent introduction. Now, we can ask it questions like, what is the price of copper? it turns out the price of copper is $0.30 per gram. Okay, neato. I don't. Is that much? Is that little? I don't. It's a lot. To be honest with you. So copper is expensive. That's why people no longer plumb their houses in copper unless they're very rich. We use plastic now, which is what a shame. Okay, so this is good, and this blob is good, but it's like super ugly, right? Like, I mean, I have no idea. It took me like 3 seconds just to scan and find the thing, right? But this is a trace, right? This tells us exactly what happened in our application, exactly where we went, when we went, how we went, everything. Okay, so what we want to do is we want to be able to convert this trace into something a little bit more consumable for Ragus. And so what we do is we use their convert to Ragus messages helper function, which does that for us. You can imagine that this is a useful feature because we're using LangChain, but as long as you can get into this much simpler format, then you're going to be able to use Ragus to evaluate your agents. That's something key. Ragus is not part of the LangX, universe. It's not part of the LCU, right? Like it's its own tool. It's compatible with many other features, many other agent frameworks, just Python. As long as we can get what we want into this kind of trace, then we're going to be good to go. So a question for you is to describe in your own words what a trace is. You're going to hear this word a lot, both because we're going to say it a lot in the remainder of our time together, but also because any job that you have, you're going to be obsessing over traces, right? Like that is the thing. That's the product that we're interacting with a lot of the time is these traces, right? As AI engineers. So now we can finally talk about evaluating the agent's performance. We've got 3 out-of-the-box metrics. One thing to keep in mind, these are just agent-specific metrics which require a trace. That does not mean things like faithfulness, answer correctness, etc. are no longer useful for agents. Those are going to be very useful still, right? We're just only calling out the specific agent metrics for this notebook. Basically, though, easy peasy, we got tool call accuracy. Again, did it call the tool at the right time in the correct way? Agent goal accuracy. How good is this agent at accomplishing the user's goals? And then topic adherence. Does the agent stay on topic or not? We're going to see how we can implement these. And it's up to you to describe how each of these are calculated. You'll have to look into the documentation. We did that exercise already, or I showed you how to do that exercise already in the RAG notebook. You're expected to do it in this notebook in order to answer the question. So tool call accuracy is going to first require us to convert our messages to a trace, and secondly, it's going to ask us to provide a reference tool call. Reference tool call. This means the correct way to call the tool. Now, there is going to be ways to generate this data synthetically through Ragus, but for now, what we would want to do is we'd want to kind of look through our traces and say, Langsmith, find one that was done correctly, and then use that as a reference. Or we can build them manually, but probably let's not do that. But you can see here that basically what we say is that tool call should be get metal price, and it should be called with copper based on this input. Okay, cool. So we can evaluate this using our favorite LLM, which is GPT-4o Mini, and see that, yes, we did good job. When we asked for the price of copper, we got the tool get metal price, which was called with copper. That's the way it should be. Good job, Ragus. Way to go, agent. All right, now what about the goal accuracy? What is the price of 10 grams of silver, right? Again, this trace is hard to read, but the idea is that we get the price. Okay, good. So we convert it to an easier to read format, both for us and Ragus, and we say, okay, it's a $32.23 per gram. So 10 grams would be, that multiplied by 10. Good job. Agent seems to have nailed it. Okay, love it. So how do we check? Well, basically, there's 2 ways we can do this one. In this case, we're going to use the with reference, which means that when we create our multi-turn sample, we're going to provide reference. This is the response it should give, right? This is the thing that it should have done. And you'll notice that this is the agent goal accuracy, right? So we don't have to put the actual answer. It's not answer correctness. It's did it do the right thing? We know that agents are going to have different answers on different days. The price of metal is different every day, right? Like silver fluctuates, copper fluctuates, right? The idea is we're not measuring if it was correct. We have different tools for that, right? We're measuring to see if it did the thing the user asked it to do. And so that's the power. Now, there is an agent goal accuracy without reference, which is basically going to say, based on the user's query, an LLM is going to come up with what the actual output should resemble. What does success look like for that particular query? In this case, though, we know it, so we just write it down and we say the agent does a good job. Good job, agent. Thank you, agent. Wow, so good. Okay, so now let's see about topic adherence, right? So topic adherence. How fast can an eagle fly? We ask this question. We get this trace, we convert the trace, and it tells us that eagles can, I don't know, they fly fast. Good job, eagle, right? But we have a metal tool, not an eagle tool. So what we have is when we try to see the topic adherence, we say the reference topics involve things like metals. Eagle's flight speed, totally off topic. We get a 0 on this one. So this is the idea, right? How well does our agent stick to the things it should be sticking to? Now, in this case, okay, let's say we're cheating a little bit. We didn't tell it not to talk about eagles, right? But the idea is that this helps us assess whether or not our agent is staying on task. Also, Hugh says that silver is not $32 per gram. It is $32 per ounce. Again, this is not measuring correctness. It is measuring the goal. Correctness would be a different measurement, which according to Hugh, the agent would fail. This is why it's important to keep your Ragus metrics around. There you go. Okay. This is the idea. This is what we're gonna do. Greg's gonna get us into breakout rooms. We're gonna crush it, and we're gonna keep these things going forward as we begin to build many agents. Back to you, Greg.
Let's go. And I believe Hugh just demonstrated the importance of putting humans in the loop. Wiz, I wanna go ahead and ask you a really important question here before we get into breakout rooms. And the question is like, why the heck did we use metals.dev? Why didn't we just extend the Simon Willison use case to add some tools to it? That seems like the obvious thing to do in this session. I want a real use case, Wiz. Why metals.dev? Seems out of nowhere.
Yeah, I mean, metals.dev is, again, it's a proxy. Put any API here. The other issue that we have is generating data to test this is not yet something that's straightforward or, we could fit into an hour. But the idea is that it's very difficult, in fact, to create synthetic data for these things.
Yeah.
The way that we would get this data is by running it in production, then having it, and then testing, right? And so we have to stick to examples that can show us how it's working in a reasonable way. Yeah.
So they don't have a framework for this, and if people want to know about how they might go about generating synthetic data, you could probably pseudocode walk them through it, but it doesn't actually exist today. Right.
That's correct. We don't have a robust enough SDG pipeline to generate valuable data for this.
All right. So let's go ahead and build our agent app, test our agent app, do it with Ragus while it's still called Ragus, and play with metals.dev, see if he was right, see if the AI was right. We'll be back to close out class. Hope you guys have a great second breakout room building, shipping, and sharing this agentic application. See you soon. Out here. All right. So we've covered a lot today. We built, shipped, and shared 2 different apps, and we evaluated 2 different apps with many different metrics. Lot to do here today. Remember, Ragus is not going to give you the absolute answer. It's great directionally, but you're going to have to decide what right, what correct, what good means to you. Agents today, they're harder to generate synthetic test data for. Remember, get those apps, get them in the user's hands, get them into production, get that data, use that data to generate more data. Think through your problem. You want to go deeper on thinking through evaluation? We've got you covered next week for Vincent's deep dives. More on eval, more on Ragus, go deeper. You want some accountability to keep building, shipping, and sharing? Maybe build, ship, and share your first thing publicly. Join me first thing on Monday morning, 9 a.m. PT, in the lounge, the public Discord lounge, for a bunch of the legends there. Join us next week where we deep dive, deep seek, and you can also find us at the usual times in the usual places. With that, let's get to feedback, everybody. 2 minutes. Please let us know what you thought. Shout out your favorite peer supporters and peers. We will shout them out next time in class. Let us know what you thought about the day. Thank you so much for everybody for joining us for session number 8. That's been 4 weeks together. Man, time has flown by. In just a month, we have learned how to build, ship, and share production LLM applications, from RAG to agents to multi-agents. Next week, we talk about fine-tuning. Remember, you know enough already to be dangerous, so go out there and start being dangerous. Today, we look forward to seeing you on Tuesday, where we'll talk about fine-tuning embedding models to improve RAG, and we'll do a little bit of work to figure out how we're going to build, ship, and share for Demo Day, guys. Thanks for joining us. We look forward to seeing you on Tuesday, and have an awesome weekend. We'll see you in office hours. We will see you guys on Discord. We'll see you on LinkedIn. Don't forget, tag at a Makerspace. Keep building, shipping, and sharing. You know we'll do the same. See you Tuesday, everybody. Bye, guys.
Yay. Bye, everyone. Have a great weekend.
Goodbye.
Great catch, Pursoon. Let's go.
Let's
Later,
go.
everyone.
Todd, any chance I could borrow you for 2 minutes?
We got a special request there for Todd
Uh-huh.
LLM. Prompting.
Who is that? I can help somebody.
That's Nick. I pinged you in the thing too. I'll send you a separate Zoom though, because I think this one's gonna close out.
Jump in the lounge, maybe? Jump in
Let's
the lounge?
go.
All right. Later, guys. Have a good weekend.